Okay. Now I'm going to introduce a couple of the case we can do with the spread. Okay. In this example, instead of using the number, I'm going to use the color IO box because color IO box is much more intuitive. Yep. So let's create the color IO box. And bring up the inspector. Create this color IO box. Change row 2. So we can 2 row. And if you change the slice count node to cosine row, okay, we can have something like this. So now I'm going to change the color. One is green and the other one is red. Yep. So my scenario this time is I want to repeat the green 5 times and I want to repeat red 3 times. So 5 times green and 5 times red, 3 times red. How we can do that? Okay. So that kind of situation is normally you confront when you're dealing with the data in 4B. If you type select, okay, you must select the color node. Yep. Yeah, select is special node for that kind of job. So if you create another integer IO box and create the 2 row and change into slice count node to course rows and pages, okay, and if you put the 5 in first row and 3 to second row, and if you're connecting this one to here, and this output from integer box to select pin, and then you can create some kind of list. So how many slices we can create? 8, yes? We're supposed to create 8, right? So here, we can see that, 8. So let's check the result. So copy this one, and then change this slice count of the row as 8. Then you can see that. Yeah. So this one is a little bit different from difference with from resemble. Resemble, do you remember the resemble? Yeah? Yeah. Resemble. Yes. So, for example, if I wanted to repeat this pattern, green, red, green, red, green, red, green, red kind of things, okay, we need to use the resemble. Resemble color, and if you're connecting this one and changing integer for resemble count 8, oops, 8, we just copy this one and connecting to this one here, and if you change into the repeat, so we can see one bang, one bang, one bang, one green, red, green, red, green, red kind of things. Okay. And then if you change the option for, if you change the mode for resemble, for example, the point, yeah, they feel half to green, half to red. Yeah. So this case, you cannot control how many gonna be the green and how many gonna be the red. Yes?
So which one do we change?
The second pin, if you change it to the pin point, yep, we can do that. Okay? Okay. So that is the difference between the select and the resemble. The select is, I think, very often used when you rearrange or manipulate your spread data. So you must remember what the select do, how you can use that select. Good. Good. So now, what about if we connecting this one? Okay, let's create another color box. Okay, this one. Okay, blue. This time, this scenario, I wanted to create some kind of patterns with this one. Not that, but okay. So sorry. Let's change this one. Okay. Sorry. I'll do something. Something with that. Okay. So. I quickly made something and then explained that. Okay. What I wanted to do is, I want to add this one in between this line. So what mean is, this color, look, my scenario this time is, this one is become, I want to add the red in between these two. And I want to add red color in between these two. Okay? And I want to add red color in between here, in between here, in between here. How we can do that? So this case, we're gonna use the special mode called the Stellon. If you click the Stellon node and press Ctrl-I, Inspector, you can have, in Inspector window, you have option for input count and output count. So let's change input count to 3. Input count to 3. and creating another resemble spread for resemble for the color. So if we add this red spread in between each slice, how many slice count are we going to have? Five? No, this one is a 6. 11? Yes, good. So you know how we can create, yes? And this one is, okay, let's do the 12 because the last things we, do the same things too. So now we have this one and this one and this one, this one. So first thing we need to do is we need to split this data into the color value. So the reason I'm doing that because I wanted to use hue and the saturation and the value, this kind of data. In some way, I'm going to spread into 2 different components. So for example, if I attach to the vector split in here, like that, like that. If you're connecting the every point with the vector split, and then this one, this x value is become this information, and y value is this information, right? Yep, makes sense? Because we grab some information, and which means the vector means we take 2 slice informations. Yeah? So if we use that some HSV joint again, like one, like here, and if we use the y value to connecting to here and here, so we have as you can see that we first grab this one information here and the second information here, right? So now what we have to do is somehow we connecting this one with this range. So if I connecting this one to first input, no, proceed. This one is the second input, and this one is the first input, and this one is the third input. And if we copy this one, yeah, we can do something like this. So we add this one in between here, in between here, right? But still has the problem because I wanted to add red in between every slice, yeah? Slice. So there is another things to solve the problems. It's called pairwise. Pairwise. Okay. Okay, pairwise. So if you're connecting this one in here like this, and then if you connecting, create the I/O box. I think this one is fine. 5. Okay, this I/O box in the second input I/O box. Yep. Okay, so look at this. If we apply this one, yeah, they first execute first index slice, and then divide into 2 color. So they divide into 2, and then they add in the middle, yeah, and then they move into the third one, right? Third one, and they create the one, and they give some space in between here for the red one, yep, and then they going to do that. So there is some mispoint in here, right? Mispoint. So we want to add red color spread in every slice. Look at this. If I doing that, middle, and first, and then first. Okay, bin size is 2, 1, 3. Oops, that's 1. What's going on? 1, 2, 1, 2. 4, 8. No. Okay, so instead of using that Stellon, I used the different one in insert slice. Okay, so we already have a look get slice, set slice. Yeah, in set slice we select a certain index number and change the value. In the same way, but in a really different way, in insert slice, you can provide the insert slice number. Okay, so set slice actually replaced your indexed slice value, but insert mean is they add new one, and then create new slice. So for example, I have this color slice, 1, 2, 3, 4, 5, 6. Yep. And then I can extracting the index number from this slice, like this way. We can calculate how many slices with count. And then if you apply with I spread, then they will tossing the index number like this. And then we can add one more, because what we want to do is adding this the purple color in between here, right? In between here. So that means they starting from the 1. So 0, and then we insert purple color in at index 1 and another color index 2, index 3, index 4, things like that. Okay, so they do the same thing. So we get the index number and we upgrade index number. So if you copy this one and then see that number, you can see that index number is now been changed. Yep, 1, 2, 3, 4, 5, 6. So they still use this one as a reference, and then they add each index number, this purple color in each index number according to here. All right, according to this one. Then, finally, we can have something like this. Yep, something like this. So one of the reason I introduced these kind of things, for example, if you want to create this triangle, unfortunately I don't have the, can I borrow your pen? Okay, so look. If you want to triangle like this one, yeah. So that's the center point is here, right? And the center point 1, 2, and 3, and 4. This first one is on the center point, right? And 5, 6, 7. So all the time is we have A, B, outside 1, outside 2 triangles. So the risk for this kind of thing is outside 1 and the center, outside 2. Like this, yeah? Then we'll repeat the pattern. Outside 1, outside 2, outside 3, outside 4, things like that, yeah? So we can, this one is exactly same as with this one, yep. So we add in the middle every 3 things. So that means if we use that kind of logic, we can create some kind of a triangles. Okay? So triangle is often, probably, if you wanted to create some kind of data visualization, for example, you might have chance to use the triangle shapes. Okay, so if you wanted to create the triangle shape, you need to grab some outside point, and also you need inside point. Then you can rearrange the data in the same way we did with Destero. Then we can have the triangular data. This makes sense? Okay, good. So that's how we can use that standalone data and insert one. Okay, so I'm going to introduce another one to CDR and KAR. Okay, and couple of many things, so I'm going to introduce that. So if you copy this one into connecting to CDR color and CDR CAR color, okay. CAR color. Okay. So CDR, CAR, they have the two output pin. So one is the remainder, and the other one is the last for CDR, and CAR is first slice and then remainder. Yep. So if you want to like 100 of like for example I think half file. Oops. So if you want to, so from the long list of the data, if you want to select just the first one, and then wanted to make another spread for after the first one, you need to use the CAR. And then the other way around, if you want to get the last one and create the another spread for the remainder, you can use the CDR. Let's have a look what is going on here. Okay. So if you connecting to this one in here, it must be the 5. This one is 6. Yep. This size for this spread is 6. But once you're connecting this spread into the CDR, the remainder is going to be the 5. So I'm going to change this one into 5. Okay, 5. And then last color is red, yellow. So they have the last color yellow. Yep. And the CAR is exactly opposite. So if you connecting to the first one, and if you connecting to the remainder, is next like this. Yeah, can you see that? Okay. So sometimes create another one. Sometimes another case, sometimes you want to add all the spread the value. That case we can use the integral. Yep, integral spread. And then if you click the help file, you can see integral process. So they add, this is offset. If the offset is the 0, okay, they add, first is add 0, and next one is 0 plus 1. And the next one is they add the previous 2. Yeah. And blah 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 blah, things like that. So if you wanted to get the result for summation of all these spread value, we can connecting the CDR because the CDR, we can easily extract the last slice information, right? So if we see that integral process again, the last result is indicating all summation of these slices. So if you're connecting this one to here, so the summation of this process is 6. Yep, that makes sense? Yeah. So the question is where we have to use this one, right? Where we have to use this one. So for example, so I'm gonna show you some case we can use this one. So let's create the circular spread and then transform to the, and then connecting the XY value and connecting the port. And attach the renderer. And toggling the screen. Yeah. And here to okay. So now I'm gonna create 3 random spread. And then create another integer IO box, and then connecting all 3 things. So what I'm going to do is I'm going to create 2 different circle, but have the difference, details. So one probably in the 5 side, and one might be the 10 side. I don't know. It's up to the random spread things. So 10 and 3000, and I'm gonna change it to 200. Okay. So if you're connecting this one to X, this one to Y, and connecting the 2, and ABS. And plus. So I'm going to use this the random spread to produce different spread count. So spread count must be always the number positive number. So you need to attach that ABS because the random spread they generate in the negative value as well. Yes. And then, if you say, for example, with 10, so random spread they always creating from negative 10 to plus 10, positive 10, right? So sometimes it's become close to the 0. But if we want to draw the circle, it's always need to be bigger than 0. Right? So that's why I add the plus, that is become kind of the minimum value for detail. And then they give you the float number, but spread count, we do not need the float number, right? We need integer number. So there is another node called flag. So they divide into, they separate between the integer number, integer section, and the rest of the float section. And then if I connecting to here like this, so let's check that uniform scale. Make it small and change the width, spread a little bit wide so we can see. So okay, so we have two separate the circular spread. If we're doing that, everybody doing that? Yes. Okay, so if you wanted to, at the moment, the random spread generating how many? Two slices, right? Two slices. So if you extracting to here, and for example is low 2, so they create 7, yeah, one for the 7 slice spread, 7 circular spread, and the other one is a 3 circular spread. Yep. Yes. Okay, so once again, look, we use the 3 different random spread, one for the x, one for the y, and the other one is spread count. So spread count is normally, if you wanted to create circular, is normally bigger than 3, right? Yeah, makes sense. So we change the width of the random spread for the spread count, 10. We can change the 20 if we want, okay, 10, 20. Then random spread, they produce negative and positive value as well. So, but we can't use the negative value for the spread count. So we need make everything is positive number. So we attach the ABS. And also the random spread produce from negative maximum width and positive maximum width. So in between there might be the 0, the number close to the 0. Okay. So that's why I give some kind of the base guideline 3. So all the number put through that pass is bigger than 3, right? Yes. So now we did this one integral, right? Integral. So what I want to do is I want to apply color, okay, color spectrum. Color spectrum. So like if we have like I want to apply the color like this way. Color spread 1, 2, 3, 4, 5. 1, 2, 3. Okay, so this is color spread. Color spread. I want to divide into whole count of this detail. So like at the moment is 4 for the one circular spread, and another one is 12. I want to add all together. So it's 16 details all together. Yep. I want to divide this one into 16, and then I want to apply one by one, like that. So to do that, we need to calculate the summation of this one, right? Yeah. But this time 2 is okay. But if you wanted to create, the 100 things, we can't do them manually. That case, we need to use integral, this one. Yep, integral spread. And if you're connecting to here, and add another SDR, then last value is 16, yep. Good. Good, 16. So now what we're going to do is one of the famous I spread. And if you connecting the last slice into second pin, we have 16s. 16 spread, yep. Maybe the number is a bit different. Okay, someone 16. In my case, this is 16. It's different. All right. Yeah. So is it the output size must be the same as the summation of these two spread? Yeah. And if we divide with this number, okay, so let's do that. Okay, this is index number. If we divide this value with 1, it means we can have step for the color. Make sense? I think so. Right? So now, if I apply this one to HSB joint, yep, and connecting the hue, so they have the 16 color, and then change the saturation a little bit. And if you're connecting to this one into the quad, you can see that. Can you see that? Joint. Yep. So you can see that, right?
make sense?